Okay, so let's look at this problem. So it's of diagonal traversal. Okay, so given an m cross n matrix, return an array of all elements of the array in a diagonal order. Okay, so it's not exactly a diagonal order because a diagonal would have been like straight lines. So okay, let's just check how it works. Okay, so let's look at the dashboard now. I hope that my screen is switching. Yep. Okay, let's take this problem, understand this problem first. So right now we are given array, a 2D array, right? A matrix basically. 6, 7, 8, 9, right? And they want us to traverse like this, right? So okay, so if we want to traverse like this, we get this. So they want to print like 1, 2, 4, then 7, 5, 3, 6, 8, 9. Yep. Okay, so this would be the output for this. Okay, let's take this question from a fundamental perspective. uh, okay, let's take this array only, this 2D matrix, and check if we simply wanted to traverse this in a uh, let's say in a diagonal manner like this, right? Then would have been 142, 142, 753, 869. Okay, so okay, let's bifurcate that. 124, 753, 669. And if I bifurcate this, 42753, 8, 6 and 9. Okay, interesting. uh okay, so what okay, yeah, got it. So if in this traversal I just reverse the every alternate item, we will get the same answer. So every alternate item, so we will get the same answer. So if I in this I reverse this, so we will get 2 4, then I reverse 7 5, oh 7 5 3 will be in order, then I reverse the alternate 6 8 would 8 6 would become 6 8 and 9. Okay, so what I need to do is basically I want to traverse in a diagonal manner, and I have to inverse every alternate item. Okay, so again, so the fundamental problem is how will we traverse the in a diagonal manner. Okay, so so if I see for each diagonal traversal, we are going from here to here, and right, if I just check this, that from going from here I printed the first one as 0 0, then I print the second one as let's assume that what assume this is a row and this is a column, right? So row 0 column 0 would be this, then row 1 column 0, row 0 column 1, right? And then this in the third line we have row this row 02 column 0, then we get row 1 column 1, then we get row 0 column 2. Similarly, if I continue for this pattern, we will get column row 2 column 1, then row 1 column 2. Okay, and lastly would be 2 column 2. Okay, 2 comma 2. This would be my pattern. So okay, if I notice here that like for traversing this, what we are essentially doing is like we are reducing this at one point and increasing the other one, right? That's why like it was simple. So like if I want to traverse in any diagonal, I need to like reduce one from the like row and add one to the column, that then only I can make a diagonal move, right? Okay, yeah, it was evident. Okay, that's a basic diagonal property. We would not have. Okay, this is much of a redundant work. Okay, so now I have this. Now I just have to need to figure out the boundary. Like I don't want my uh, matrix boundaries to get overshoot, because then it will throw a null pointer exception, right? So okay, so if how will we figure out the boundary conditions? So can we say that if any of these become 0? No. So can I just check on this only? So if I say, that's like pretty evident that we can't go below 0. So if I just wait a second. Wait, we can erase this, we don't want this. Okay, so okay, so for boundary conditions we basically need that this should not overshoot. So basically we need to stop if like like a traversal would be 2D, right? I and j. So like take row and column if like if column becomes less than 0 or row becomes less than 0, move next. Okay, if column becomes row becomes move next. If Next would be overshooting, so this would be undershooting, like we become actually less than 0 going back. Next is overshooting, like we become more than the length itself. So if row becomes greater than row length, let's say, or column become greater than column length, right? So these would be the then move next, if move next, right? So these seem to be the boundary conditions. Yes. So if I just dry run this on my current logic, what will happen? I am right now here. My column is not less than 0. So I will just say print and move next. Print and move next. Right. So I will print 1. Just move this. Okay, we can just move this. So I'll print 1, then I will say in the next move my column will become less than 0, because I minus 1 would, sorry, my row would become less than 0. So like I would just say move next, right? 1 second. So it would be in else, this would be in else. So if we are within boundary conditions, I will just say print, else I will say move next, right? And I think these conditions can be combined, like if column is less than or row is less than 0 or row is greater than these conditions can be combined. So so move next, what actually it will do, we will figure out what move next will do, but I think these conditions can be combined. Let me just see. So if row is then let's say row length or call greater than call length, okay, let's just skip. So basically these conditions would move here, right? So we'll print, if any of these conditions fail, we'll say move next, right? So what will move next to? Move next will basically, if I say increase my row, move to the next row, right? Because we are starting from the row and going to, what about after this we'll go column. So move next will basically trying to figure out what it will do. Okay, so move next. So move next basically increase row. If row can't be increased, then right. Let's move next. So basically say row plus plus, so row would become there. Like if row is less than equal to row length minus 1, then we'll say row plus plus. Okay, and we'll say continue else if some condition of our column plus plus continue, right? Okay, so I come here, I print 1, right? Then one of the condition fails, I have moved to else what will do, it increase my row, so row will move to here, and row will move to here. Then I'll say continue, so it will go here, right? Then I will go here, then I will print 4, will 1 second. Like for printing, I think I will need another for loop here, huh? In terms of ij, because I don't want to like manipulate the exact values for that. So track row. What's the expected output would be in integer? Okay, integer array. Okay, actually have to reverse as well. So let's first focus on printing the diagonal, then we can see on the reversal part. Okay, so if like these are the pointers for my current, like these are just the pointers, but these are real row and columns, right? So this is basically row 0, column 0, right? And these are pointers. How we got these pointers? It's in the for loop, huh? If we take a outer for loop of row and column, then now why would we take a outer for loop? Like to complete the traversal, I have to complete this as well. Like this also I need to complete. So if so it will be the while condition, while, so like the boundary, I'm actually writing the whole code right now, but yeah, while row is less than equal to row length minus 1. Similarly for the column. Now if I increase like I don't want to decrease the actual row, And what if I take the dummy row? Okay, let's take a, this is a row pointer, not actual row. This is a column pointer, not actual. So these are our pointers. Now if I go with that approach, I will say, okay, row and column have not reached to its end. Okay, and over. And I will go 1. Then if, now what will be the row pointer? Row pointer would be the actual row where we are right now. So we are at the actual row, that would be 0. So row pointer would be also pointing to this, or column pointer also would be pointing to this. So for 1 it is straightforward, right? Now what will happen is row will move down because we first check row. Now row has not completed, so we'll say row plus plus and continue. Now we check the row has not reached end, column has not reached end. We will assign row pointer here, okay, column pointer also here. So we'll say okay, row pointer and column pointer both are here. We will print that. Then we will decrement the row pointer by 1, that becomes 0, and increment the column pointer by 1, that becomes 1, so that becomes 2. Okay, then like we check, and we will get move next, so move next we will get 7, then we will get 5, print, then we get 3, then move next, get 8, then we get 6. Yeah, so this approach should work. Let's quickly code this up. Let me switch to the screen. Okay. So we took around 23 minutes to come up with that approach. Still slow, I would say. Should have been a 10-minute job. But let's quickly code that up. So complete this question in half an hour. After that, I would see how, like, what was the actual level for this question. Okay. Anyways, so first of all, let's initialize all the variables. So we will be taking a row pointer. Let's not talk about pointer. Let's a row, right? So it's the row actual. Then we have int row mn is less this int row, int column actual. Okay, column actual is still 0. Int row length th. So length would be my, and do I get a mat of, so row would be any 0th I get, and I say ngth length, and that's row length, right? That's column length or what? It's row length. Okay, int column col length, which is equal to mat dot length. Okay. So now what we'll do, so we won't even need a while loop. We can cover up in the for loop, and I think in for loop, if we by default we will traverse the row first, and then we will, okay, so instead of, let me just show weird So let me just show. So I took a while loop here, and then I incremented the value in the move next. I don't think I need to do this if I take a for loop simply, and then I will take two for loops because I want to traverse, and obviously the inner for loop will be for the uh, row. So after completing that, I will automatically like increase the inner loop, and yeah, like I think this can be auto managed. Like obviously I will be traveling the row first, then I would be increasing the column. What if I reach here? What if I reach here? So I will complete this row, then I need to increase the column, but yeah, I don't know if for loop will work. No, let's take a while loop only. Okay. Okay. So weird. For one second. Preferences. Hmm. Okay. For some reason my hotkey. Okay, it stopped working again. Weird. Let me just assign some the hotkeys. Okay, is it working now? It's not again working. This fucking. That's weird. Okay, I'll switch manually, no issue. Okay, so we have this for. So we will take the while loop. Inside the while loop, what I will say that the row actual should be less than equal to the row length h minus 1 and call okay, I think I can just say call actual less than equal to my call ATH. Okay, now okay, so if I'll just say now I will initialize my pointers, right? Yep. So we'll just say int row pointer equal to the actual row actual, and my int call pointer should be equal to my call actual. Right now, if my row pointer is greater than row length minus 1, or row pointer is less than 0, right? I'm thinking if my row pointer is greater than the, so basically I have offshoot the row, but I will never offshoot the row, like since I'm never increasing the row, I will never offshoot the row, right? I can only offshoot the column. So like if I simplify this condition to row ptr, I can only go negative in the row, like I will never offshoot the row, can I? No, because every time I'm only decreasing the row, so doesn't make sense. So should be greater than equal to 0, and why? And right, because or would not work here. If my already row is negative, there is no point moving forward, and then my column is not overshooting. My column should be less than equal to the total call length minus 1. Yeah, or it would makes more sense, because like here my column is not overshooting, but okay, I think or would make more sense, because if that's the case, else what we will do, else we will just say move next. So by what we meant by move next, like if else we will just say move next, right? So for move next we will just say if we have the row is less than equal to row lng, okay, sgths, always make the spelling mistake here, minus 1. So we will increase the row actual, say row actual, okay. If call actual is less than equal to call length minus 1, we'll just say call actual plus plus, okay. So once that's done, come here, we'll get the new values, we'll say here, and we will just get that's actually an integer array. Okay, weird choice of output, but let's say int result is equal to, that would be this new int, and the total number of elements that I would have would be n cross n, right? Like that's a given. So that would be row length into column length. So that would be it. And it won't even accept a. Okay, that's a weird choice, man. Anyways, insert in result. Okay, I can just take result tracker. So just say result pointer is equal to mat of row pointer call pointer. Okay, and then obviously I have to increase the result pointer. Okay, so okay, let's once try run this. So we have all these values. Let's try run this on this example, right? So that's no, I mean it will be 1 2 3 4 1 2 3 4. That's a basic example. Let's try run on this only. So currently I am looking for an output of 1 4 2 7 5 3 8 6 9. Let's see if I can achieve this from this. So we'll start with the actual. So these all will be done. Then row actual would be 0, which is obviously less than equal to the row length, which is 3, and call actual would be less than equal to that's given. So row pointer and column pointer both would be 0. Now if okay, what? Okay, one second. So row pointer, actually I need to put a for loop in here, I guess, right? Because it will again like move the row. Okay, to put like a for loop here because I need to traverse the whole row. What it will basically do will reset my row actual and call actual. What if I take it outside, then what happens? But then it will not get reset. Okay. Okay. Thinking now. Okay, just do one thing. If I just say I say while, and then I will just to satisfy my OCD, I'll do this. What happens now? So insert in result, move next. Okay, so now I will move this till I exhaust this. So while row pointer is greater than equal to 0 or call is less than equal to 1, I will continue here. But again, in my case, when I print 1, how much time? Okay, we have already spent 41 minutes here. No problem. So if I sort, if row pointer is greater than equal to 0, let's say it is not, so it becomes false, and this becomes true. Then I will again go here and I will store the long results. So if row pointer is greater than equal to 0 and call pointer, man. Actually I have to, like, 1 second. Like I have to manipulate these as well, right? So result pointer plus plus, to decrement this row pointer minus minus, then call pointer plus plus, because that's basically move diagonal, ठीक है. While row pointer is 0, so if I reach here, then the column actually has not exhausted. So column call pointer which was 0, yeah, so this is row, this is column. Okay, so it has reached a boundary. But no, column will never reach a boundary. Column will only reach a boundary when it is here. And like column will always increase. Column is not decreasing. So again, back to my original condition. So column will also increase. In this case, the column is decreasing. But yeah, going here is increase always. So so row pointer. Okay, move result pointer. Okay, so my row pointer. Okay, move diagonal, move next. Just getting confused on the boundary. So row pointer should be greater than equal to 0. Call pointer should be less than equal to call, and there should be an OR. So if I am here, so this is not. So if I just say row pointer should be greater than or equal to 0, and call pointer should be less than or equal to call in the -1. So true false become false, and I move forward 4. Okay, so in move next I will increase the row actual. Row actual is now here. The row actual is at 1. Call pointer is still at call pointer is still at 0. Row pointer is 1. Now is row pointer greater than or equal to 0? Right. Row pointer is 1, so it is now is call pointer less than or equal to total call -1? Yeah. Yes. So I think this should work. Let's run this. Okay, it's a compiler. Call pointer. Here as well. Okay, I have not returned the result. So after doing a return result, what is happening? Did I miss something? Okay. So okay, something went right. 142 753 then 000. Okay, so I want to 142 753 I was able to print, then it became 000. So in any case I would like reverse out these, so I'm not much concerned about these. I'm concerned about that these should be printed at 869. So this call actual should be less than or equal to call and -1. But am I saying that after reaching here the call actually became no, not changing call actual here. Let's okay. So 142753. Then I should increase the, since row actual is less than or equal to row length -1, but row actual would be 3, right? So row actual would be row actual would be 2, and row 3 that would be less than or equal to 2. It's going wrong. This printing's correct. I know that something is going wrong here. Okay. I hope that this one's a medium. If it would be easy, then 1 hour would be too long of a time to like come up with this. Anyways, let's now focus on solving this. So dot length. Okay, that makes sense. Insert and result. That all makes sense. So this is like working perfectly. The only thing is I call actual. I'm not manipulating call actual right now, but row actual should be less than, so when I reach here, when I print 3, at that point my row actual would be 2, right? And my column actual would be 0. So if my 2 is less than equal to 2, my 2 is less than equal to 2, no it is not actually. Let me just quickly print that, right? So system out dot println row actual. Let's print it here, okay? Just want to cause it out. Okay, okay, so my row is 1, row is 2, and now row became 3, but row should never become 3, right? But okay, let's say that it becomes 3, right? And I come here, I stop. Actually, okay, I stopped here. I don't know what I'm going to do next. Yup. So my row actual is less than equal to, which never happened. Okay, so these conditions are clashing. As soon as my came 3, I came here and my all actual never got executed. So as soon as this becomes true, and no, but no. Okay, did I forget that right now, or was it never there? Yeah. Anyways, uh, so my row became, let's say my row became 3, right? Now my row pointer becomes row actual, which is 3. Should not be, na? 3 is not a row here. So first of all, I should not be putting this value here. And anyway, so okay. So row actual should be less than equal to row length. Again, it became 3 because row starts from 1. Is it so? Huh. Row is starting. Okay, let's do one thing. Let's say start. Let's start. What's the value at end? Run. Alright, so at start we have 0 0, then became 1 0, then became 2 0. At start 2 0, at end it should never been 3 0, right? It should never have been 3 0. Why has it become 3 0? What? Row actual. Okay, 1 second. -2. So, okay, so what the hell? Row actual should be less than equal to row length -2. Why? Because I don't want to increment my row actual again. To stop that, I moved here. Okay, but yeah, this like satisfy the condition and my problem is solved. Wow. So we stayed around 5 minutes on debugging the issue. Anyways, okay, whatever. So what I will do now, so this prints the row in a diagonal fashion: 142753869, 142753869. Perfect. Now what I need to do is we'll just say I just need to like reverse the result. Sounds easier. But you are saying that you need to reverse the result. So if I do I just need to like, okay, let's take one thing. You are inserting it on the fly, 0 1 2 3 4 whatever, okay, and here you are saying that I want to insert after this iteration completes. Uh-huh. Okay, okay. Okay, so let's do one thing. So I know that, like, if I generalize, so each 0 1 2 3 for each odd iteration I have to reverse print. Each odd iteration I have to reverse print. So end is alt itr, like is alt alternate iteration. Obviously no, it will start with the false. Now when I'm moving to next row, okay, so like is it depending on this, what is it depending on, like at each iteration I'm alternating this, so is alt iteration false. I move next row. So I'm moving next row. I'm pretty sure that I'm moving to the next row, right? Right. So I will just reverse it. One second. So I will just say, when I move to the next row, I'm pretty sure is alt itr, it becomes negation of is alt itr, right? Yeah, I just reverse it. So okay, so now I have a like this. So if is alt itr, so what am I doing is just saying that I am saving the insert in row result. This one insert in result. So we have already we are about to cross 1 hour here. Insert in result. Now this would be here. So row result would obviously reset after each iteration. So int row result is equal to end array of this equal to new int, and that would be what? So the row length is consistent, so that would be of row length, right? And that row result at what point? pointer tr equal to 0 to this pointer. And on coming here, what I need to do, if is alt else, like in both cases we will increase the result pointer, so you can just take it out here, right? If is alternate row, then we will do something else. No, one second. One second. So first we will have to like reverse it. So let's say reverse row ptr, and right now I have rows, right? So and result pointer. Okay, one second, man. Okay, it will be simple. What we'll do is for int equal to 0. No, it will start from the rows pointer dot length. I would be, do I have to run it as 0 case? 0. Okay. I minus, right? Like similar for loop for this, but it would run in forward to 0 is then rows pointer dot length I plus plus. Now what will happen is result of pointer is equal to rows pointer I, right? And also result pointer plus plus similar thing here, right? So if is alt itr will reverse the loop, insert the entry in this, and let's run impulsively. It should yeah, obviously it's a compile error. So yeah, 1 hour has already passed, still a compile error, my bad, that's a boolean. Okay, length length, that's true. So error record but found. Understand what it is trying to say. So int cannot be dereference. Int rows pointer. Oh, my bad. So yeah, why would great, that's just good. If I just comment it for a second, because yeah, I'm not inserting anything here, so what's going on? Problem is with these for loops only. Just run. It runs. So the problem lies in this. Ah, what? Yeah, row as route length would be the total length. So I would have to traverse it with the, like, it starts from row pointer. This goes to row pointer. Okay, that's 102. 753 got printed correctly. 06. That's weird. So I know that I'm missing a small thing. You just do one thing. One zero. Why is it becoming zero? So one is understandable. Okay, so I so okay, one, else I will not go. I will say okay, it's true now. Okay, this works as it is. I will go ahead, this also works as it is. So that's so this also works as it is. So I come here, I say that okay, is alteration is true. Okay, what if I do the same? Okay, so it should print the same result, right? If everything is correct, it should print the, and it prints the same result. 4, 2, 5, 3, 8, 6, 9. So this prints means the issue is somewhere here, right? I start from row pointer. I start from the, like, I know that I have 4 2 in my array at this moment. So and my row pointer is, what's my row pointer? 0 1, right? Let's say I'll start from 1 and go till 0, right? That's my motive. So I'll start from 1. I'll say if I, that is 1 is greater than 0, yes it is, then I'll subtract it, so that becomes 0. I become 0. Okay, so 0 1 because my root counter, that makes sense. 0 2, if I would choose 0 2, that makes sense. But after everything, this makes sense. So it's also working correctly. There's something looping issue road is. Starts from row responder, starts from 1. So can you print us what's the left row responder? PTR 2, 2, but it never became 1. PTR 2, PTR, row res PTR, row res PTR. That makes sense. 2 1 comes to 0. Okay, my bad. Okay, got it. So okay, yeah, I think this solves it. Let's put in the custom test case, this one. Okay, let's try to submit this. Wow, great. 2 3. Index 1 out of bound for length 1. So for 2 3, what would be the output? Like it would be 2 3, right? Was that like expected would be 2 3, your input, your answer, should if. So for 2 3, what would be the output? And next one, out of bound for length 1, because like row actual would be for 2 3, row would be row length would be 2, column length would be 1. I really don't know where this actually. So that also works for this case because it has 0 and call length. So works good. SPDR 0. Okay. So I ran for 1 0. So row actual became 1. That's bad. Yep. But row actual became 1, then row length, that is 2 minus 1, that is 1, that is equal. Then again, call length minus an index, row length 1. So you are saying, okay, so call length plus plus also, call length would be 0. So I started with 0 0, I became 1 0, then I do this as 1, this is 0. Why would I do that? Okay, so again, so I'll put this. Now row pointer is going to equal 0 and call pointer 0 would be 0. Hmm. Just where I can do that. Okay, let's do one thing. Oh, my bad. Such a silly mistake. So yeah, the row length would be matrix dot length and the column length would be mat 0 dot length. Anyways, happens. Submit. Yep. Hmm. Shit. Okay, so finally, yeah, we solved the question in almost 1.5 hours. That's that's a lot of time, Arto. Anyways, let's at least it got solved. Uh, let's take a look at solution. Okay, so common strategy for solving a lot of programming problem is to first solve a stripped down simpler version of them and think that what needs to be changed to achieve the original. Our first approach to so based on this is so instead of thinking about zigzag pattern of printing diagonal, let's say the problem statement thinking as well. Yep, that's what I did, one diagonal after the other, starting with the okay, yeah, that's what I did, right? So the first and the last column in this problem would serve as the starting point for the question diagonal. Given a diagonal, say ij, we can either go up the diagonal by going, or we can go down the diagonal. Note that this applies to the diagonal to diagonal that go from right to left only. Okay. Yeah, this is a simple problem to solve. The only difference between this one and the original problem is that some of the diagonals are not printed in the right. That's all. We simply need to reverse the odd number diagonals before we add the elements to the final result array. So for example, yep, yeah, so like the thinking of that is correct. I think we came up this with this approach in like half an hour. But the actual time I took was in implementation part. Yes. So here's the initialize the result array that we will initially return. We would have an outer loop that will go for each of the diagonals one by one. As mentioned before, the elements in the first row and the last row would actually be heads. The heads are their diagonals. We then have an inner loop that iterates over all the elements in diagonal. We can calculate the number of elements by doing some simply okay. For each diagonal, we need to need a new list or dynamic like data structure. Since we don't know what size to allocate, again we can do the math, include this. For odd number diagonal, we simply need to add elements and reverse out. So yeah, our algorithm was same. What the fuck is happening here? Okay, similar to mine only. What is happening? Okay. So okay, so it has a check for empty matrix, so this check should be there in a production grade code. We missed it. Variables track the size of the matrix and matrix. Yeah, but so that's where the like absurd mistake happened. It actually took an array list. Okay, and what did it in the last is it took intermediate dot clear. So it's okay. Start to process. So it took the intermediate. Okay, this like kind of like row is. Now go the first row and the last column to code. Clear into the head of this diagonal. Don't like this code. Like my code is not also very good, but yeah, this. Okay, and here the reverse was also simple. Anyway, so it's to simulation. It's pure simulation. I really need to understand the walking depending on its direction. So I u plus 1. Interesting. Interesting, this looks interesting. Okay, let's go to the solution section. Java. Okay, leave Java. I just sort most recent most loads. What the hell? one pass solution. Hash map. Hmm. Okay, this looks a better solution. So, got it. So the main idea for that each diagonal sum should be the number of diagonals already. Traverse 0 0 row plus column for second diagonal 0 no row plus column equal to 1. Okay. So is up is a boolean. If it took a for loop. So matrix dot length plus matrix 0 dot length. Okay. So battery dot length. 2 by 6 would be running 6 times, right? Right. It can be 3 into 2, 4 plus 4, 8. Okay. Now I plus plus if is up while current row is greater than equal to 0 and current column is less than matrix, so it's a matrix. So okay, we can actually move this like this. Much easier. Right. Yeah. Oh, 1 second. Okay, so if is up while this if current column equal to matrix 0 dot length, current column is equal to minus 1. Okay, yeah, this one is a good solution. I will take a link for it. Right. So it just took an is up variable to check whether if we are going up and down basis that they have done their calculation of on a row or a column. Okay, great. So yeah, that was all for today. I originally planned to do it till like 12:30, but yeah, took 1 hour 15 minutes extra. Good night.